Welcome back. Today we're taking parallel data, making it serial, sending it down a wire. Let's talk about that. Let's say you have data that you want to transfer from one digital side to another. And data is usually 8 bits. So to transfer that data, you are going to have 8 wires. One per bit. Bit is a 0 or 1. Let's not get into too details into technology here, but think of it as a wire that is either has power, that's 1, or doesn't, that's a 0. And data is usually 8 bits. So you would have 8 wires. So the ones that have power on them, these are 1s. The ones that do not, these are the 0s. And this is how you can transfer data from one side to another. But it's really impractical to add 8 wires. What if you have data that is 16-bit? Now you add 16 wires. Well, you can send 8 twice, that is 16. Or let's send the 8 individually over the same wires in a row. And that's what's serializing the data. Now we're talking about like really basic form here. We're going back like 30, 40 years in technology. We're talking about how it's all started. So you had a parallel port at some point, and then they changed that to serial port. And all it did was on that parallel port, you had the 8 data pins. And then there is a pin that says, okay, new data, new data, new data. So when 2 computers are connected at a really simple form, there are 8 pins that go from out from one side into the other side, and then there is a pin where the out will say, here is more data, here is more data, or the in will say, if the in is in control of that pin, will say, give me more data, give me more data, and that's how data is transferred. Now and then we switch to serial port to simplify things so you have just a single wire to transfer the data. And instead of sending 8 at once, it will be sending them in order. That could be from the highest bit or to the lowest bit or the other way around. But then either way, they are being sent serially, meaning you have the 8 bits, one go on the output from one side, go into the input, and there's a control pin that says, okay, here is one more data, here's one more data, here's one more data. And that pin is called the clock. This, in electronics, is called a shift register. A shift register, it's shifting in the individual bits, clocking in the individual bits. So there is a shift pin, there is a clock pin, that whatever you set the input to will take in the next bit, the next bit, the next bit. So there is an input. Let me draw this right here. So there is an input, or an output from one side, and there is in on the other side. And there is signal that go from one side to the other, and there's clock. So this is the signal coming here, and then that signal goes high, goes low for some time, goes high for some time, whatever it needs to transmit. And then there's a clock. So the clock will be clock, 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 clock. So that's usually 8 times because it's transferring 8 bits. That's not a rule, but that's the common ground. So with every clock the output is sending, the input will be reading that data at that particular time. So at this time, when this clock happens, when this goes high, this is high. So this is saying, okay, the next bit is 1. It's high. Now in this case, if we go to the next clock right here, the pin is low, and the next one is also low. So in this case, we're transferring 1, 0, 0. So this will be a 1, this will be a 0, this will be a 0, etc., etc. This is how you transfer data. Now there is a peripheral that is based around shift registers and this technology. It's called SPI, Serial Peripheral Interface. So SPI is a very common interface, and this is available on about every microcontroller out there for a way for the microcontroller to talk to other peripheral devices. What example peripheral devices? Well, in this example right here, I have this chip right here is an MP3 decoder, MIDI decoder. It understands audio formats, and it has like a connection to to connect like speakers or headphone. And this is connected to your circuit using SPI, Serial Peripheral Interface, and the data is being transferred just how I showed you in a second earlier. So you can grab any board that can accept the Arduino pinout that is compatible with Arduino form factor or Arduino itself, and then you would plug the shield on top, and now the processor is connected to the shield to this audio processor chip using the SPI bus. And through SPI, there's clock, there's data. There's actually two data. One is going out, one is going in. So there's back and forth communication to do. It's the same thing, except there's two of them. One going out, one is in. And this is how these two communicate to where the processor will be sending like the MP3 file, for example, to the decoder chip to play audio. Another example right here, which is also a shield. This also can plug on top of your board. And in this example, it's a display. This is also an SPI display. And this SPI display will, when you send it like an image, text, whatever, you send it data that shows on the screen or configuration, that's also being sent over the SPI bus. Now, what I want to talk about today is even a simpler form of the SPI bus, or using the technology we're talking about, which uses a shift register. Now, a shift register, and here is an example of two shift registers that are sitting on this module right here. This is a board. This is somewhat common from China. You can find it on eBay and many websites that have, it's like Chinese products or Chinese vendors. So this is very common, low-cost relay board that has 16 different relays on here, and they are connected through an 18-pin on this side. Now, let's say you don't want to connect 18 pins from your microcontroller, and you actually shouldn't. Why waste 18 pins? So what we did over in this example, is add two shift registers. Each one is 8-bit because, like I said earlier, 8-bit is very common. Each one is 8. There is 16 over here. So each one of these is connected. The output from these shift registers is connected to one relay. So I would send in my serial data to which one is 1, which is on, or 0 is off. And I can control all these relays using 2 pins only. One is the clock, and one is the data. And I can bit bang these. We had a tech talk about bit banging, meaning I can control these in software, or I can use the SPI bus. And a shift register will look something like this. So you have a chip. Let me make it a little bit smaller. So there's a chip right here. There's a clock in. And you have the 8 outputs. So this is 1 through 8. And this is CLK for clock. And this is data in, coming in. This will be data out from the processor, data in going into the shift register. So like we said earlier, there is a clock and data coming in, and you're sending them these 8-bit at once. Now, if you don't understand this in details, just use the SPI bus. That's already supported by any platform you use, including TinyCLROS. So in TinyCLROS, you would start an SPI object, and you would send a byte. Whatever byte you send, the binary representation will show on these outputs. One of the pins is the latch. So the latch is, you would toggle this pin when all data has been transferred, because you don't want these pins to change while you're sending the data in. You would send all 8, and then you would say latch on the output. This you would connect to chip select on your system. This will be connected to master out, slave in, and this will be connected to serial clock. These are the 3 pins. And that's what I have on the relay board we talked about, and that's what I have also here on this click module that's connected on the BrainPad. So the BrainPad might be the easiest way to explain this. I would have, in this example, I have 4 shift register because I have 4 times 8, 16, 32 LEDs on here. And those 32 LEDs connected to these 4 shift registers. And I would be sending 4 bytes, right? Each byte is 8 bits. I'll be sending in 4 bytes. And these 4 bytes will show on these LEDs, the outputs. Now the output can be a system that's reading in data, but over here I'm using the outputs to control the LEDs. On the relay example, I am using them to control the relay. On this example over here, same thing, there are 4 shift registers, and so this will be like right here, like the drawing. This is the shift register, the inputs, and these are the 8 outputs coming from that shift register. Now, for fun, I also added the delay between every time I send data, and of course we'll be providing this code so you can take a look at it. What I did here is I said, well, delay depending on how much how much light is coming into the brain pad, since there is a light sensor. So when there's light, the delay is higher. You see the LED changing slowly, but if I cover it to make it darker, you can see that the LED moves faster. If I make it super dark, then the data is transferred quicker, meaning going on to the next byte. And all I have in my code is a simple shift operation that goes on to the next LED and next LED and next LED. This is it for Serial Bus. I hope you found this beneficial. We'll see you next week.